Hello students, welcome to the new class. As we know that in the previous class we studied about the beta distribution of first kind and second kind. In this class we will study about the another special continuous probability distribution, which is the exponential distribution. This exponential distribution is one of the easiest distribution in the series of continuous probability distribution. When we can say that the set of the data follows the exponential distribution, or we can say that any continuous random variable x having an exponential distribution with a parameter theta. Here, the parameter involved having a value greater than 0 and its probability density function. Why we are saying probability density function? Because x is the continuous random variable. If it is continuous, then the probability density function will work. So then the value of the probability density function f of x is equal to theta into e raised to the power minus theta x, and that x takes the value positive value. We can say that any positive value, even 0 also. That's why we write here x is greater than equal to 0. Otherwise that value of the probability density function is 0. This is a general definition of exponential distribution. Now, after getting the probability density function, our aim is to find out the moments. So, we will use a moment generating function for calculating the different moments. So, we know that m of x of t is equal to expected value of e raised to the power tx. After getting the value of moment generating function of an exponential distribution, our aim is to find out the different moments, or we can say that in generic we will calculate the rth moment. That value of the rth moment is equal to the expected value of x raised to the power r, which is equal to the coefficient of t raised to the power r divided by r factorial, and that value is equal to the r factorial divided by theta raised to the power r. Therefore, we can get the value of mu1 dash, that is equal to 1 upon theta, and mu2 dash is equal to 2 factorial divided by theta square. Thus, we can find out the value of the variance, and that variance is given by mu2. We know that. So, the mu2 is equal to mu2 dash minus mu1 dash whole square, which is equal to the 1 upon theta square. This implies that the variance in the exponential distribution is greater than its mean if that theta lies between 0 to 1, and if that value of theta is equal to 1, then mean equal to the variance, and if the value of theta is greater than 1, then the variance is less than the mean. For the different value of theta, the relationship between the variance and mean is varying. Now, in the exponential distribution, there is a lag memory tells us about the conditional behavior of exponential random variable. It is one of the key result which we will use in driving the solution of queuing system. Another topic in the field of statistics. We will study about this topic in the future classes. If that random variable x has the exponential distribution, then for any constant, we can say that a which is greater than or equal to 0, one has a probability that y is less than or equal to x, given x is greater than or equal to a, is equal to the probability of x less than or equal to small x. And here the small x is the value of capital X, where the value of y is equal to x minus a, because we are taking the any constant a. If we want to prove this equation, we will use the probability density function of the exponential distribution, and that is equal to the theta into e raised to the power minus theta x, and the criteria x is greater than or equal to 0 and theta takes the value greater than 0. Then we have the probability y is less than or equal to x intersection x greater than or equal to a, which is equal to the probability of x minus a less than or equal to x intersection x greater than or equal to a. Then we can write like this: probability x minus a plus x intersection x is greater than or equal to a, which is nothing but equal to the probability that x is greater than or equal to a and less than or equal to a plus x. Now we can see that x lies between the a to a plus x. Therefore, by using the probability density function, we can write like theta into integration a to a plus x into e raised to the power minus theta x dx, which is equal to the value e raised to the power minus theta into a into 1 minus e raised to the power minus theta x after solving the integration. And what is the value of the probability that x is greater than or equal to a? It means we have to integrate from a to infinity, because x takes the value, any value after a, so we will integrate a to infinity. Therefore, that probability equal to the theta into integration a to infinity e raised to the power minus theta x dx, which is equal to the e raised to the power minus theta a after solving the integral. Similarly, we can calculate the value of probability x less than or equal to small x. It means we have to integrate from 0 to x, equal to theta into integration 0 to x e raised to the power minus theta x dx, which is equal to 1 minus e raised to the power minus theta x. Therefore, in the previous classes we studied about the conditional probability. So here we will use the formula of conditional probability. So the probability of y less than equal to x, given x is greater than or equal to a, is equal to the probability y less than or equal to x intersection x greater than or equal to a divided by probability of x greater than or equal to a. After putting the values of the different probabilities that we already calculated, this value is equal to the 1 minus e raised to the power minus theta x. Therefore, and this 1 minus e raised to the power minus theta x is equal to the probability of x less than or equal to small x. Hence, we can say that the exponential distribution has lack memory. In the next class, we will study about the linear combination of independent exponential variate. Thanks for attending this lecture. Hope you will get the basic knowledge of exponential distribution.